Okay, sorry about that. If you watched the last recording, I tried to squeeze in one more before the time ran out and I was unable to. So I have a new problem. So anyway, mean is 65, standard deviation is 6. So I just want to do one more empirical rule problem. Okay, remember, this chart minus the red you want to use for every single empirical problem you do, always. Okay, nothing changes in the blues, so to speak. What will change with every problem you do is the red. So if the mean is 65 and the standard deviation is 6, you start with the mean, start here at 65, add 6, one standard deviation higher is 71, add another 6, two standard deviations higher is 77, add another 6, three standard deviations higher is 83. Go the other way, subtract 6, you get 59 for one lower, subtract another 6 for 53, that's two lower, and you subtract another 6, you get 3 lower. Now you'll be able to answer every question. So do that first for every problem in the empirical rule. Start with the mean, add, subtract, subtract, subtract. Then you'll be able to answer any question they could throw at you. Remember, 68% of the widget is within one standard deviation of the mean. Okay, 95% is within 2, and 99.7% is within 3. But this asks 68%, which is within 1. So you look at one higher, one lower, and you'll see that it is 68% right here. So your answer will be between 59 and 71, okay? All right. Lie between 53 and 71, okay? So between 53 and 71, let me get rid of this here. So between 53 and 71. So again, you have this chart. It's real easy to answer any question they give you. And the answer to that is, when you add those up, is 81.5, okay? And then the last one is above 47. So let me get rid of this. So above 47, so you would start here and go all the way to the end. Or, as you know, this entire thing is 100%, right? What's 100% minus 0.15%? Because that's all that's not included. Or you could go ahead and add all these up. Whichever one you want to do. It's quicker to just say 100% minus 0.15%. And of course, that answer is 99.85%. And that will close the book on empirical rule here. It's pretty simple. Okay, the z-score, okay? In the empirical rule, everything was either one higher, one lower, one higher, two higher, three higher, one lower, two lower, three lower. Now, what if the score fell in between like 1 and 2 standard deviations, or between 2 and 3 standard deviations, or between -2 and -3 standard deviations, or something like that? Well, we want to see exactly how many standard deviations is that score away from the mean. And that's what the z-score is. The z-score, basically, you're going to calculate it, but it's important you know exactly what z-score means. I'm going to pick a data value. If I know the mean, which is 77, right? Okay, standard deviation of 2.1. And I've got all these test scores, say. How many standard deviations from the mean is the score 78? Well, 78 is just higher than 77. So the z-scores could be negative or positive. If the data point in question is below the mean, you're going to get a negative z-score. Or if the data point in question is above the mean, you're going to get a positive z-score, okay? So how many standard deviations is 78? We know it's higher because it's higher than the mean, right? How many standard deviations is the score of 78 higher than the mean, okay? Well, the formula is, if you get that little chart out, which I encourage you to keep that chart out too, because you'll be referring to it a lot, is x minus the mean divided by standard deviation, x being the data value, in this case 78, minus the mean, which is 77, divided by the standard deviation, which is 2.1. And hopefully, let's see, 1 divided by 2.1 is 0.4762, rounded to 4 places, okay? Make sure you pay attention to how many places you want to round it to. By the way, again, if you guys are struggling on rounding, get it straight now. Ask somebody, ask me to help you, get our tutoring center involved. You need to be able to round this entire course. That's not going to end, all right? So the data value, which is x, minus that little thing, the mean, divided by standard deviation. In this case, a positive z-score, because we knew it was going to be higher. And think about it. Think of the empirical rule. One standard deviation higher is 79.1, right? 77 plus 2.1. 78 falls between the mean and one standard deviation higher. So we knew it was going to be somewhere between 0 and 1. We knew that, okay? Oh, and I forgot to mention about this part right here, okay? If the, no, I grabbed a different problem. These problems rotate, so I can't grab the same one once I'm out of it, okay? If the z-score is within 2 standard deviations of the mean, okay, which means it's between 2 and -2, then it's not considered unusual. So in other words, here's my little thing that I had up before. Okay, I'm gonna make it a little better than that. Okay, just trying to use my mouse. Okay, so here's the mean. That's 2 standard deviations higher, and that's 2 standard deviations lower. So that's z equals -2 and z equals 2. Okay. If you get a z-score that's either higher than 2 or lower than -2, it's going to be considered unusual. Any score between any z-score, in other words, any score within 2 standard deviations of the mean, 95% of them, if you remember the empirical rule, is going to be considered a normal or not unusual test score. Anything outside 2 standard deviations from the mean, in other words, 2 standard deviations higher or more, or 2 standard deviations lower or more, which means your z is either higher than 2 or less than -2, will be considered unusual. So 2.66, obviously higher than 2, it is considered that. So this score, if the class mean is 76, this 88 is really considered an unusually high score compared to this data. Okay. Very high because it's more than 2 standard deviations higher than the mean. So not many people will be scoring in the high 80s in this. If you're randomly selecting test scores, very unusual. I'm going to find something in the high 80s, and it's very unusual. I'll be finding something. Let's see, 76 minus 9 is 67. Very unlikely I'll find something less than 67 as well, because 67 would be a z-score of -2, right? Right. So this, if the mean was 71, standard deviation of 3.9, 66 is a little bit more than 1 standard deviation lower than the mean. Well, we knew it was lower because we knew we were going to get a negative z-score because 66 is lower than 71. If you do the math, I'm not going to go through it, we just did it. It's negative 1.3, so to speak, and it is between -2 and +2. The z is between -2 and +2, so it is not considered unusual. This one, oh boy, the only thing I'm going to say about this one, I'm not going to go through it. I don't want to be too repetitive on these. I want to keep these videos somewhat short. But one thing I will say on this is just convert. I had people ask me in the past, well, this is 6'3", what do I do? Well, just convert it to inches, okay? 6 foot, how many inches are in a foot? 12, right? So 6 times 12, I'm bad with math in my head, is 72, and then add 3 inches. So 6 foot 3 inches would be 75 inches. So let me just go ahead and snip this. So this would be 75 minus 69.7 divided by 2.65, okay? And then there's your z-score. And then woman is 5'11", all right? Oh, I'm glad this came up. There's one more thing I want to mention. So 5'11", so that's 5 foot 5 times 12 plus 11 equals, see, 5 times 12 equals plus 11, 71. Okay, all right. So just convert them all to inches. And so now this one, basically, even though what they're saying is who is relatively taller within the group that they're in, okay? Well, that was wrong before. So anyway, it would be the mean is 64.3 for a woman, okay? All right, yeah. So when you calculate the z-score, what it means is doesn't matter who is actually taller. Obviously, a man that is 6'3" tall is definitely taller than a woman that is 5'11". But compared to the people in their group, so to speak, in this test group, men and women, who is actually taller relative to the rest of the people in their group? Well, all that means is who has the higher z-score. Okay, so this woman is 2.6 standard deviations higher than the mean. This guy is 2 standard deviations higher than the mean. Relative to the rest of the people that she was compared against, she is higher, relatively higher, because her z-score was higher. Okay, and remember, negative 1.5 is greater than negative 2. So if they were both negative, you would take whoever's closer to 0. So negative 1.5, if I got 2 z-scores, what negative 1.5 and negative 2, I would choose the negative 1.5. Negative 1.5 is greater than negative 2.